given that HCF of 306 and 657 is 9, find the LCM of 306 and 657. We are given that the highest common factor of 306 and 657 is 9. Using this, we have to find the least common multiple of 306 and 657. We know that LCM of two natural numbers a and b times the HCF of those two natural numbers a and b will be is equal to product of those two numbers a and b. That is LCM of AB, a comma b times HCF of a comma b will be equal to a times b, where a and b are natural numbers. So we are given HCF. Using this, we have to find the LCM. It is just a matter of dividing the product of a and b by the HCF of a and b. Instead of a, we have 306 here, and instead of b, we have 657 here. So LCM of 306 and 657 is equal to product of 306 and 657 upon HCF of 306 and 657. We are given that the HCF of 306 and 657 is 9. So it is just a matter of dividing the product of 306 and 657 by the number 9. That will be resulting in 22,338. Check whether 6 raised to n can end with digit 0 for any natural number n. We have to check that 6 raised to n, a number of the form 6 raised to n, can end with a digit 0, where n is a natural number. We know that for any natural number to end with a digit 0, it should have 2 and 5 as its prime factors. Any natural number that will end with a 0 will have 2 and 5 as its factors. Any natural number that ends with a digit 0 must have 2 and 5 as its factors. But we know 6 can be factored as 3 times 2. 6 is equal to 3 into 2. So 6 raised to n is equal to 3 times 2 the whole raised to n. A times b the whole raised to n is equal to a raised to n times b raised to n. So 3 times 2 the whole raised to n is equal to 3 raised to n times 2 raised to n. 6 raised to n will be of the form 3 raised to n times 2 raised to n. But 3 raised to n times 2 raised to n does not have 5 as its prime factor. 3 raised to n times 2 raised to n do not contain 5. So 6 raised to n can never end with 0 for any natural number n. So there is no question of 6 raised to n ending with 0, since the factorization of 6 raised to n is 3 raised to n times 2 raised to n. It does not have a factor, namely 5. So it is a number of the form 6 raised to n will never end with a digit 0. Explain why 7 times 11 times 13 plus 13 and 7 times 6 times 5 times 4 times 3 times 2 times 1 plus 5 are composite. In order to prove that a number is composite, it is sufficient to prove that that number is having a factor other than 1 and that number itself. Any number having a factor other than 1 and that number itself will be a composite number. So consider the first number 7 times 11 times 13 plus 13. This is the first term and this is the second term. From the first two terms we can take 13 outside. 13 is the common factor. So it is equal to 13 times inside bracket 7 times 11 plus 1 bracket is closed, which is equal to we know that 7 times 11 is 77 plus 1 is 78. So this would be equal to 13 times 78. Therefore, first number, this number is having two factors other than 1 and that number itself. So it is a composite number. Similar is the case with the second number also. Consider this second number. This is the first term and this is the second term. See, from the first two terms we can take 5 outside. So from the first two terms we can take 5 outside. So we will be getting 5 times inside bracket 7 times 6 times 4 times 3 times 2 plus 1, bracket is closed, and this expression gets simplified to 1009. Okay, now the second number, this is the second number. The second number can be expressed as 5 times 109. So this also is a composite number because this second number is having a factor other than 1 and that number itself. The second number is having factors 1 and 1009. So these two numbers are composite. Both of these numbers have factors other than 1 and the number itself. So both are composite numbers. Find the LCM and HCF of the following integers by prime factorization. The numbers are 8, 9, 25. We have to find the LCM, least common multiple, and HCF, highest common factor, of the integers 8, 9, 25 by method of prime factorization. First of all, we have to write these three numbers as the product of prime numbers. 8 can be prime factorized as 2 times 2 times 2, which is equal to 2 to the power 3. 9 can be prime factorized as 3 times 3, which is equal to 3 squared. 25 can be written as the product of prime numbers as 5 times 5, which is equal to 5 squared. We can see that these three numbers have no common factors. They have no common factors. So their HCF is equal to 1. See, so these three numbers have no common factors. So their HCF, highest common factor, is 1. Also, 8 and 9 have no common factors. 8 and 25 also have no common factors. 9 and 25 also have no common factors. So LCM will be just the product of these three numbers. So LCM will be 8 times 9 times 25, which is equal to 1800. So the LCM is 1800. There is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? This is the circular path. This is the circular path. Sonia and Ravi started running from the same point. This is the starting point. Yes. Sonia and Ravi started running from the same point at the same time and in the same direction. Sonia completes one round within 18 minutes. Ravi completes one round within 12 minutes. The question is, after how many minutes will they meet each other at the same starting point? Reaching the starting point again means completing one full round. If a person start at the point S and he reaches the starting point again, that means he completes one round. Yeah. As far as a circular path is concerned, reaching the starting point again is completing one full round. Let Sonia and Devi meet each other after X minutes. We don't know what is X. What is the value of X? Let Sonia and Devi meet again after X minutes. By this time, Sonia have completed M rounds. Suppose Sonia have completed M rounds by the time they meet again at the starting point, because reaching the starting point again means completing one full round. So let Sonia complete M round when they meet each other. Let Ravi complete N rounds when they meet each other. Sonia takes 18 minutes to complete one full round, and Ravi takes 12 minutes to complete one full round. So Ravi and Sonia meet each other after 18 minutes. That 18 should be equal to 12 n. That 18 should be equal to 12 n, because Ravi takes 12 minutes to complete one round, and Ravi and Sonia meet each other at the starting point after Ravi completing n full rounds. So Ravi and Sonia meet each other after 12 times n minutes. That should be equal to 18 times m minutes, and both should be equal to x. That is 18m should be equal to x and 12n should be equal to x. There are so many x satisfying this condition, but our aim is to find the minimum value of x that satisfies this equation. Now the problem reduces to find a common multiple. Find the lowest common multiple of 18 and 12. That x should be a multiple of 18 and it should be a multiple of 12. We have to find an x. We have to find the value of x which is the lowest, satisfying both of these conditions. That means we have to find the LCM of both 18 and 12. The problem reduces to finding the LCM of both 18 and 12. In order to find the LCM of 18 and 12, we will do the prime factorization of both the 18 and 12. We know 18 is equal to 2 times 3 times 3. It is the prime factorization of 18. And 12 is equal to 2 times 2 times 3. We know how to find the LCM. LCM is equal to 2 times 3 times 3 times 2. We have to avoid the GCD getting multiplied 2 times. So we will be multiplying all factors of 18 with the non-common factor in 12. So the LCM is 2 times 3 times 3 times 2, which is equal to 2 times 3 6. 6 times 3 18. 18 times 2 36. So the answer is 36. I think you have understood this. So we have completed the second module. We will be continuing with the third module in the next class. Okay, thank you.